Class, this video is going to help with 2.4, which is scatter plots. And we actually cover more and more about this correlation and regression and calculating out regression lines and things towards the end of class, so end of the semester. But what is a scatter plot? Remember, a scatter plot, oh, well, I didn't even have that as my first definition. Never mind. We'll get there. So what is a correlation? A correlation is a relationship between 2 points. And we can't see that without the scatter plot. So a correlation is a relationship between 2 points. A linear correlation is when you plot the data and it forms a line. So both of these correlations you see through the graph of a scatter plot. So what does a scatter plot look like? So here's 3 examples of what a scatter plot looks like. It is basically XY points, right, that are a relationship between 2 things. So like maybe your weight gets bigger, or weight versus height, right? And as your weight gets bigger, typically your height gets bigger. So this data right here might be your weight and height. Now, you might have some outliers in there. Those are people that are way off, you know, that are really tall but weigh little, and really short and weigh a lot. So for the most part, if we look at the scatter plot, it'll tell us what our correlation is. This is an example of a linear positive correlation. Forms a line, and it's going up. We focus on linear. I mean, it could form a U, a quadratic, right, a U shape. It could form kind of just a curve, and you have to look at a different type of correlation as well. But we're looking for linear for this one. So negative, right? You start big and you're going down, will be a negative correlation. As you get more, you're getting less coming in. So 2 things that might have a negative correlation would be, wow, I can't think of an example all of a sudden. I'm out. I don't know why I can't think of one. Just off the top of my head, I should have wrote one down. So negative correlation is looking something like that. And if I have 0 correlation, no correlation, it's kind of just our dots are everywhere, like this last example. I'm going to Google this. Negative, why can't I think of one? Correlation. I'm going to do linear. Examples. What do they have? Well, okay, you're not coming up with anything for me. All right, so we have actual numbers that we're going to use to find whether something is really related as well. So let's look at that in a second. So these can form other patterns. We just want to know that we're focusing on the linear when we talk about our linear correlation. And the more straight the line is, the stronger the correlation is. So if it's a little more spread out, it might have a relationship or correlation, but not a strong one. And then if it's everywhere, then we say no correlation. All right. Oh, I have one now. I Googled it. As the weather gets colder, your air conditioning costs decrease. So as the weather gets colder, your air conditioning costs decreased. There was something that, yeah, that's the only one I see. Okay, there's an example. All right. The book talks about clusters a little. Not something you probably have to worry about, but there can be gaps in clusters, and it still has no correlation, right? That's not really forming a line. It's not forming an x squared or a square root symbols graph. There's really no correlation there. Now, here's what we're going to use, and we'll use technology, so I'll show you that in a second, to find what we call our R, and that's our correlation coefficient, and it measures the strength of that linear relationship. So I can use the computer to tell me how strong the relationship is. So the closer you are to the number 1, the stronger your relationship is. So if I'm 0.99, that is an amazing relationship. 0.8, I like to think of it as 80%. That's pretty good. 0.7, still not bad. 0.6, pretty bad. 0.5, not a good relationship, right? All the way down to close to 0 would be no relationship. And it falls true for a negative is going to be close to -1. So the closer you are to -1, the more of a relationship you have for our R value, correlation coefficient. So let's go ahead and go into StatCrunch. If you want to write those numbers down, you can pause and write those down. We're going to do these in StatCrunch. So stop share my screen again with basic screen share. That is not what I did. Share screen, basic, share. Thank you. All right, so StatCrunch. One person was struggling with getting into StatCrunch. Make sure your pop-up blockers are allowed and that you've gone through the tech to set up your tech exactly like Pearson wants it. Even in Apples, you have to go through the preferences in Safari or Chrome and set it up, or StatCrunch doesn't pop up. Okay, so my first category, we changed the name up here. I'm going to call these shoe lengths. And over here, I'm going to call this height. And my shoe length was 29.7, and my height is 175.3. And that's one person. That would represent one data. The next one maybe is 29.7 and 177.8. The next one was 31.4. Please put this in your StatCrunch as I am as well, so you can make sure you can do it. 31.8, 175.3. Oops, 31.8. 311 and 27.6 and 172.7. Okay, so there's our data. So first, let's make that scatter plot. So graph and scatter plot right here. So you have to pick your X variable. Well, we'll do our shoe and our height as our Y. So we'll go over shoe, up height. You could do it the other way. It just depends on what you want for your data. And I think we're good. The rest is probably fine. You could change that stuff up if you want. There we go. There is our scatter plot. Sort of looks like it forms a line with one data off a little. All right, so if I want to find the R, I'm going to go to Stat, Summary Stats, Correlation. Take a second, write that down. Stat, Summary Stat, Correlation. Okay, and I'm going to click and where group correlation of column with itself. Now I don't remember. R is point optional. Shoe, Control Shift, heights. Goodness, now I'm going to compute. Yeah, it does give it to me that way. Okay. There we go. So let's go through that again. Edit. I forgot. So okay, when we start this, neither one of those are highlighted. You click it, and I have to click Control Shift to get both of them. And it tells you that on here. You have to do that a lot. So I want it of this data over here. These are the options. So I might have data in like 50 rows. Or 50 columns. So I have to click the 2, and I want correlation compute. I think there's another way to do this too, but that is our correlation. 0.59. I feel like that's kind of like a D, right? It's got a correlation, but not a strong one because this is throwing you off. All right, so, and just a couple reminders. No line correlation doesn't mean there isn't a nonlinear relationship. We are focusing on a linear correlation. And a Correlation does not imply causation. I have a relationship between my shoe length and my height. But does that mean your shoe length causes your height? No. There's just a relationship between them. Bigger your feet, usually, the taller you are. All right, another thing I'm going to show real fast. I'm going to show this in Excel also, and this is for my business students who want to use Excel a little more often. And so what I'm going to do is I'm going to put my data in again. I wonder if I can cut and paste it. I don't know. So 29,175.3 and 29.7, 177.8, and 31.4, and 185.4, 31.8, and 175.3, and last one, 27.6, and 172.7. Okay, so for this, I never highlight anything in StatCrunch, but in Excel, they like highlight. And then I'm going to go to Insert, and I'm going to actually go to Insert a Scatter Plot. And from the scatter plot, I click the plus, and I can get my trend line, and I can get more options. My face is going to be in the way, so I'm going to move it up here, and I can display your equation of your line and your R, and I make sure it's linear, and that is displayed here. I want to show this because notice it shows my R squared, not my R. R squared's a little bit different. So I can use my calculator and take the square root of that. So 0.3496. I'm going to then take the square root. I did this in the wrong order. Square root of 0.3496, and I get the 0.59. So you can still get it, but no, there is a R squared correlation coefficient is R correlation. What is R squared? Yeah. I can't think of it all of a sudden. I'm not going to worry about it. We will cover more about R and R squared in the end of the textbook. But for today, what is our R? Our R is telling us our strength in the negative or positive, and we can get that through Excel or StatCrunch. And basically, you're making scatter plots today. So taking data, making a scatter plot, noticing outliers in your scatter plot. This one here. Which one is that one? I think it's this one. If I take that off, it then changes. Well, no, it made my R squared lower. I don't know. It still doesn't look like that strong of a relationship. Okay, so let's go ahead, and that is really all we're doing. This section I found was pretty quick. What's a scatter plot? You probably made them before, and the R might be new, and we could get that just through technology. Oh, you could get it on the graphing calculator as well. Correlation coefficient. You might have to Google it.